Thanks everyone for joining. Hope you're staying safe and healthy wherever you are. This will be super quick today. Just want to draw your attention to a handful of new features that have been incorporated into the product and into the console. Specifically, we'll look at the decentralized membership onboarding, some new B2B business-to-business communications that we've added, document store app-to-app messaging, improvements to IPFS and Chainlink, improvements to billing and the creation of what we call suborgs, allowing you to have different organizations basically under a single domain, improvements into our Swagger interface for easy interaction with your smart contracts and methods, event streams, and then a few things around protocol and environment configurations. So I'm going to skip the typical slides that I share and just dive right into the product here. So I haven't done anything. We have a blank canvas here, and I'm just going to go ahead and start by creating a business network or a consortium. I'll call it testnet for lack of a better word. Click next. I'm going to choose my home region. We see here that we have different regions in AWS and in Microsoft Azure for choice. So these will be whitelisted clouds and whitelisted regions where we can host any containers, any services, or any nodes or any deployments on the platform. So I'm going to choose AWS in Columbus as my home region. And now we can turn this into a hybrid or multi-region or multi-cloud network, meaning that all these that we whitelist right here will be available to, again, host nodes and host resources. So there's the scaffolding for the network. Now we can choose to build it out in one of two ways. We can create memberships, and memberships are a construct essentially that just own services. They're bound to security credentials, they're bound to nodes, and they're bound to services. So memberships are useful if you want to mock out how your network is ultimately going to look, or if you're going to be operating or proxy operating resources on behalf of another entity. So maybe I'll create a membership called Bravo Organization right here. And then I can create nodes and services and bind them to either of these organizations. They're both owned by me, either of these memberships, excuse me. One of the new improvements that we've added, though, is now the ability to decentralize your network through very clean, simple, email-based membership onboarding with role-based access control embedded inside of it. So maybe I want to onboard, organization 123. Not coming up with very creative stuff today. So we send the email to the administrator for that organization, admin@email.com, just a dummy address. And now ourselves as the founder, as the initiator of this blockchain business network, this consortium, we can choose to allocate or rescind certain permissions on the network. And we see that we have 5 to play with, very self-explanatory, but do you want this organization to create nodes that are going to participate in the algorithm? Do you want them to be able to manage and upgrade environments? Environments are our domain or our firewall namespace for a blockchain. Should they be able to onboard other organizations, create multiple memberships like I just showed you, or manage smart contracts? And that's a construct that we'll demo here inside of this walkthrough. So very, very straightforward. This is all documented. So you can choose to, give them carte blanche, access to all the admin privileges that you have, or rescind some of them. So send that invitation, you see it here, and it'll remain in pending state for 72 hours, and they can choose to accept or decline based off their business requirements. So boom, really, really simple to, go either of these routes or go both of these routes here based on the needs or the stage of the project that you're at. So there's the business network. That's the high level scaffolding. Now we can choose to actually create a blockchain. We call that an environment. And within your business network, probably goes without saying, but you can have many, many environments. And that makes sense for standard DevOps procedures here. You might want a sandbox environment. You might want a user acceptance testing, a pre-prod, and then ultimately at some point you're going to want your hardened stack to be driven at a production environment. So we see we give you 2 doors to go through. We've done a bunch of walkthrough Wednesdays and Tech Tuesdays on Corda in the past, so we'll focus on Ethereum today. Click next, just give it a name. I'll call this, Dev1. We can choose if we want it to be cloud only, or we also have support for what we call Kaleido private stack, allowing you to run a self-managed node in your own on-premise infrastructure or in your own private cloud account. So you could, run this in GCP, or you could literally run this in your own on-premise data center. So this is available for customers running on our enterprise tier. If you do want more details, or if you want to have a conversation about this, or if this is a requirement, feel free to reach out directly to me, or you can just use this simple contact us button right here. So I'll go with the happy path, the easy path, cloud only. And just as a caveat, if you guys are interested in sort of that private stack route, we do have previous recordings of Tech Tuesdays where this has been demoed in a lot of detail, and a lot of architectural diagrams are shown as well, showing how this security works and how that private networking and secure tunneling works as well. Okay, so back on this path. So we choose the Ethereum route. Now we see that we have 3 different node clients or providers to choose from: Geth, Quorum, or Besu, and they each have corresponding consensus algorithms. What we've seen typically for the vast majority of production enterprise deployments is a Quorum and IBFT orchestration, although we're seeing more and more interest in Hyperledger Besu now, especially after the announcement of the acquisition of Quorum by consensus as well. So one thing I want to point out here, and I know these have been covered in some previous webinars and potentially yesterday in the Tech Tuesday, but when you are creating your environment, there are a few really simple advanced settings that you can employ. You can choose your own custom chain ID. You can customize the block period if you want basically quicker finality for your transactions. And every environment comes with a billion Ether bootstrapped in the Genesis block. So if you don't want the rest of your network or the rest of the nodes in the environment to have access to that Ether, you can essentially just drain it and add it to a pre-funded account like your MetaMask wallet or some external hardware wallet. So very, very straightforward here to employ any of these. And then there's a handful of additional configurations that you can very easily apply to your node, whereas in the past you had to use our admin APIs to do that. So essentially the long story short, or the synopsis here, is that we're embedding all of the functionality that has been there for a long time directly into the platform and making it quite simple to employ. So I'll do a Quorum and IBFT network, just leave it at 10 seconds, go ahead and press finish. And now we can bring it to life. We can go ahead and add some nodes. So I'll create a node for my alpha organization right here, call it N1, choose it in AWS US East, but I'll see that I have all of those whitelisted clouds and whitelisted regions available for me. Go ahead and click next. We see that we have a wide catalog of integrations that we can employ: key stores, backups, log streams, private traffic, role-based access control, and then protocol configurations here. So what we could do is we could create a protocol configuration. I'll just call this example config. This is just an arbitrary string for the object right here. So we'll create this object, and now when we go back to create our node, we'll see that this is available for us to attach. So go ahead and click next. This is, again, very, very self-explanatory, but we could choose to run the node as an archive node. We could set a gas price, set course policies, or make enhancements or modifications to the REST API gateway right here. So really, really straightforward. I'll just create an arbitrary configuration with a gas price of 2. Go ahead and click finish. And then we see that we have this object, but it's inactive because it hasn't been bound to a node. It hasn't been applied to a node. So hop back to my blockchain right here that we're in the process of creating a node for. I'll just go through that exact same flow again. N1, bound to alpha organization, click next. And now we see that I have that object to attach if I wanted to attach it. I'm going to skip that because we don't need to go through the ordeal of trying to fund transactions and actually apply gas. Okay, and then the last piece right here is based on sort of your throughput requirements and your architecture, application architecture, how horizontally scaled it is. For example, we have different node sizes that can accommodate higher levels of throughput and more concurrent connections as well. So I'll leave this as a small node. Go ahead and click finish, and boom, you've brought your blockchain to life. Really straightforward. So just to make the algorithm happy, I'll go ahead and chuck 2 additional nodes in here. Best practice for IBFT is to have a minimum of 4 nodes. We give you one for free with the system monitor node as well. And that's what does all the indexing inside of the block explorer and the metrics and the data explorer. So there's 3 nodes that we've added into the environment. We'll give those a few seconds to initialize. And then what we'll do is we will go ahead and upload a basic contract project. We'll use our simple storage source code. We'll look at the new Swagger. We'll look at the HD wallets. We'll emit some events. And then we'll finish up by taking a look at document exchange, app-to-app messaging, IPFS and Chainlink as well. So go back to the dashboard here. We can watch in real time as these initialize and as they join the network. Once they've joined, we'll go ahead and hop back into the business network or the consortium view, and we'll create a very, very simple contract project. Basically Kaleido's easy button for you to program and interact with Ethereum smart contracts without having to use heavy SDKs or complicated client libraries. It's just a basic REST API that we're going to serve up for you. So give these hopefully not too much longer to fully initialize and join into this environment, and then we can go ahead and create that contract project. So system monitor is good, and then all these other guys should go ahead and start up in real time here. So as soon as node 1 starts, we'll go ahead and create that contract project. And please throw any questions into the Q&A or into the chat, or even feel free to raise your hand if you want to speak out loud. These are supposed to be as interactive as we want them to be, and I'm here to answer any technical or any commercial questions that you guys have. So please don't be shy or don't hesitate to ask if you have any question whatsoever. There are no dumb questions. Okay, so these guys are taking their sweet time today, but nonetheless, we'll go ahead and sort of multitask here as they're coming to life. So back in my business network or in my consortium view, we see we have a class called shared assets, and this is where we can create our contract projects. And so this is just a construct under which you can have multiple compilations of your Solidity, of your Ethereum smart contract, of your business logic, so to speak. So I'll create one called simple storage, and then I'm just going to import that Solidity code from a public GitHub that we have. So click finish, and now I want to create that compilation. So I need to supply Kaleido with the endpoint to that .sol file, to that Solidity. So we'll call this version 1, and then we need the URL, which is hanging out right here. So this is simple storage, trivially simple right here. It just has a single global variable that's a positive integer. We initialize it. It has a constructor that it needs an argument when we instantiate it. And then it has a very simple event right here called data stored, which is going to emit every time we call the set function. So it's got 2 methods, a set and a get, and a redundant get query. And then when we call set, it'll emit this event. And we'll take a look at why events are important and how easy we've made that in the console as well. So I'll grab this string right here, feed it to Kaleido. Kaleido can auto detect everything else. So go ahead and click finish. And this will compile. We'll provide you with the ABI, with the bytecode, but most importantly, we're going to serve up a set of RESTful endpoints that can be programmed against. Very simple, very, very straightforward. So as this guy's compiling, let's take a hopscotch back to the dashboard. All of these nodes have started up successfully, so that's good news, even though they were being slow. So we can go back here to our shared assets, contract projects. We can view the project, and we can see that this compilation is still chugging along right here. So we'll give this a few seconds to ultimately compile, and then we'll go ahead and generate that gateway API. We'll promote it into this development environment that I just created, and then we'll go ahead and bring it to life. So apologies that things are choosing to act a tad bit slowly today. But we'll get through this. So there it is, it's compiled. We see the ABI, we see the bytecode, the optional dev docs, and then we see the git commit hash and the source of truth, exactly where this business logic came from. And this is great for decentralized networks, right? Everyone wants to have, unequivocal assurances that they are executing and operating against the exact same business logic. So what I can do is I can promote this into my environment that we just created. I'm going to create an arbitrary string for the open APIs, for the REST APIs. Just go with SS. And now what we can do is we can actually view these APIs. And the nice improvement that we've added here is that you're now, you're not opening a new browser here. You're staying directly inside of the console. So the Swagger interface is embedded directly inside of this experience here. So I'm going to view this through node number 1, and by default, it's going to use the node wallet, the default Ethereum account that's on that node. So we'll go ahead and open up these APIs, and down here we see that we have the pretty embedded, actionable Swagger interface that we can talk to. So what I'll do first is I'll instantiate this smart contract just using that basic account, the default Ethereum account on node number 1. So all you do is click try it out. now we have, an actual live Swagger instance here. Go ahead and give it, it's actually an integer, not a string, but nonetheless, we'll give it an argument to the constructor. We're going to leave this as the default Ethereum account. I'll show you guys how easy it is to use different wallets and an HD wallet, for example. And then another nice thing here is we can give this a human-friendly name, a readable name. So rather than dealing with hex addresses, you can choose something that makes sense to your use case, to your business network. And this is particularly convenient because we can take these APIs, we can take compilations, and we can create multiple instances of them, right? So maybe we want, an instance for different geographies or, different customers or different asset classes, but we want to use the same business logic. You can give it very logical, intuitive naming conventions right there. So go ahead and click execute. We're on Core MyBFT. I set it at 10-second block intervals. So we should see this return us the transaction receipt. There we go. How long did it take? 7.5 seconds, so pretty good. So very, very simple to do. Again, anyone that's building an application essentially is just going to program against this endpoint, the instance endpoint that we've now created. And then you can just use, basic REST API calls against the available methods inside of your smart contract. So back to the dashboard right here, we see our smart contract management. We see our instance now inside of this gateway API, and we can open this back up to interact with it. So what I'll do now is I'll show you guys another improvement that we've added, which is the HD wallet, which is now embedded inside of the version 2 of the console. So hopping down to key management right here, we see this managed wallets class, or this tab right here. Go ahead and click on that. And we have 2 different routes you can go here. Again, this is just going to be an arbitrary string, so I'll just call this example wallet. Go ahead and click next, choose where you want it to be deployed or hosted. And you can do a basic Kaleido managed wallet. This is essentially I guess a corollary of how you would do a node wallet. These are just Kaleido managed keys. Or you can do an HD wallet, a hierarchical deterministic key tree. And these are super convenient if you're managing keys on behalf of hundreds or thousands, tens of thousands, millions of end users, or if you want to use it for one-time usage for privacy and anonymity. You get like 2.8 billion keys inside of each of these wallets. So go ahead and click finish, and we'll go ahead and actually create an HD wallet once this service instance is provisioned. Very, very easy to do this. Once we've created it, we'll go back into our Swagger interface and we'll actually sign some transactions with the HD wallet. Kaleido under the covers will do all of the redirect, all of the internal API calls to go ahead and retrieve the index or retrieve that account, grab that private key, sign it, assemble it, submit it as a raw signed transaction to your Ethereum node. So your responsibility right here is really, really lightweight. All you have to do is basically teach the REST API gateway, teach ETH Connect, as we call it, about the wallet ID that you want to use. So telling me I need to upgrade my environment. Looks like we're good to go. So I'll just hop back into the managed wallets class right there. We can view the wallet, and now we can go ahead and create an instance. So this is the mnemonic. This is what will deterministically recreate the wallet with the exact same structure, the exact same account, and the exact same private keys. Kaleido is not going to save this for you. This is sort of, exactly the same way we do application credentials. It's a salt hash verification. So you are the custodian, you are the administrator of this seed phrase right here. So click done, and here we have our wallet. So we can open the wallet and we can browse any of the available accounts. And there are, I'm not lying, there are 2.8 billion accounts inside of here. So how many ones was that? I'm in the millions now, and we see that we have a unique address and a private key that can be viewed if we want. So what we'll do instead is I'll just go ahead and use the first index inside of the account, index 0, E398, and we'll ultimately sign a transaction with this index right here. So for convenience sake, what I'm going to do is actually open up another instance of this because I need to grab a few resource strings. So I'll use this window to look at my HD wallet, and then inside of this window right here, what we'll do is we'll go ahead and hop back to our contract instance inside of the interactive Swagger interface. So let's go to apps and integrations, go to the gateway APIs. we see that we have our SS API, that compilation, and within it, we have a single instance that I named SS123. So we can go ahead again and view this instance API. We'll view it through node number 1. And first, what we'll do is we'll go ahead and just call a get and make sure that we see back 123, which is what we instantiated it with. It's the return value. And now what we want to do is something a bit more interesting. We want to actually upsert a new value for the global variable, but we want to sign it with the HD wallet instead. So we'll give it a value of 99. And now we're going to change this parameter right here, this KLD from parameter. So we'll go back into the wallet. And the syntax for this is actually HD-service ID. This is your service ID up here. If you follow the URLs, they're quite intuitive. So it goes consortia ID, environments ID, and then sort of the service or the context of the product that you're in. So you're in key management, managed wallets, HD wallet, and there's the service ID for your HD wallet. So pretty doggone straightforward right there. So we're going to sign with this key, index 0 inside of the key tree, E398. So the first thing I need is I need this ID right here. So copy that, and now we're going to overwrite this. So HD-service ID. Now we need to provide the wallet ID, and this is necessary because within this service instance, you could actually have many HD wallets. You know, typically 2.8 billion accounts are going to suffice, but for whatever reason, if you want to compartmentalize, you know, different asset classes or for different usage, you can create as many HD wallets inside of here as you actually want. So we'll copy the wallet ID so Kaleido knows where to grab this address and this private key from, and then we'll go ahead and supply it with the index as well, which is 0. So just to make sure, we're looking for a transaction that's now going to be signed by E398, and this is the syntax that we're telling Kaleido about right here, and we're passing it 99. Everything else is good to go here. So again, just go ahead and click execute. You would of course be doing this programmatically, but this is a nice way to experiment with the syntax and to just see, you know, transactions successfully come into your network. So here we go. In the from field, we see E398. So Kaleido did all of that redirect and all of that signing on your behalf. So very, very simple. Okay, pressing along, I'm going to try to keep this quick, so we'll do 5 or 10 more minutes, and then I'll give you guys some time back today and answer any questions if they arise. So the last thing I want to show you, sort of within the context of Swagger, is the event streams right here. So what event streams do is essentially it's the opposite direction of the REST API gateway. So we make it very, very easy to submit transactions, but we make it perhaps even easier to consume pertinent state changes that are taking place inside of your network. So if your Solidity, if your business logic has an event defined, and if you have your methods coded to emit that event, then Kaleido is going to auto-detect all of those events inside of your smart contracts. If anything has been uploaded to a gateway API using our smart contract management feature, Kaleido will do all of that heavy lifting and all of that auto detecting for you. You don't have to manually subscribe to the events sort of inside of the Swagger interface or via an API. Kaleido is just going to surface every event that exists, and then you say, hey, I want to subscribe to all the signatures of this event, or I want to subscribe to just a specific smart contract, for example. So we'll create an event stream. I'm going to keep using node number 1 here. I'm going to call this request catcher. But typically what would happen is you'd create a little serverless function and an API gateway inside of AWS, for example, and then you just point sort of your webhook or your endpoint to that API gateway URL. I'm going to use a trivial little subdomain service request catcher right here. So go ahead and click next. I'll go into the service. We'll create one called Kaleido123. Click get started, and here's basically the webhook. Here's the API that I want to point to, if I can grab the whole string. So copy that. This is what we're going to teach Kaleido about. Best practice here is to not leave this as an open API or an open endpoint. So you'd probably want to add a security header, a bearer token inside of there to protect that. For this purpose, this is sort of just an ephemeral domain, so I'll create this as an open API here. Go ahead and click finish. And now we can go ahead and actually create a subscription. And again, since we use the smart contract management feature, since Kaleido is aware of all of the methods and all of the events inside of our smart contract, what we're going to see is we're going to see Kaleido auto detect the existence of this event right here. We're going to see that, yeah, Kaleido knows about this event, and it knows that this method has been coded to emit that event. So it's very, very simple to create the subscription now. So we'll add the subscription. I'm going to call this, again, data stored, because that's the event that we care about. Now I choose the gateway API. We only have one because I only created one. And now we'll see that that event is available for us to subscribe to right there, data stored. Again, you can subscribe to all of the signatures of this event. So if you had created multiple contract instances inside of that gateway API from that compilation, you could take all of the invocations of that method. Or if you just want a specific instance, you can go that route as well. So I only have a single instance and I only have a single API. So this is quite an easy decision for us. And then you just choose if you want all of the historical events or if you just want the latest events as well. So click finish, and that has now created a subscription on node number one. Node number one, when it has the state changes for this smart contract and that method, will emit the event to the endpoint, to the webhook that we've defined. So back to the dashboard, we can see this very, very simply right here, apps and integrations, event streams. We'll go ahead and click on this. We see that it's live and we see that we have a single subscription. So what we'll do now is we'll just invoke our smart contract one more time, and we'll hop over here and we'll see the payload be delivered, this JSON object, which is really just going to emit us the method that we call and the argument that we pass to that method. So apps and integrations, gateway APIs, here's our open API, and here's our instance. So we're going to view the instance through node number one again. It keeps wanting me to do node number 3. So we'll view the API. We'll just use the default Ethereum wallet to sign this transaction here. So post set, try it out. We'll give this an argument of, what's the date? September 2nd. We'll give this 2. And again, we're not going to do an HD wallet here. We'll just use that default account. Go ahead and click execute. This transaction will succeed. And when it gets mined, here it comes over here. So very, very straightforward. There we see the argument that we just passed and other pertinent information, transaction hash, ID, etc. So those are event streams, really, really powerful, really useful to build your own rich off-chain database or inject these real-time state updates directly into your application. Okay, last couple things. I'm not going to spend too much time on IPFS Chainlink or any of the B2B things. We'll cover these much, much more in depth on an upcoming Tech Tuesday. And they do merit, you know, their own 45 or 50-minute sessions. So I don't want to sort of shortchange their functionality or all the cool things you can do with them. But what you'll see here now is inside of the B2B Communications class, you can go ahead and click the dashboard, and you can very, very easily create new instances of your document store and document exchange service or app-to-app instances. So we can go ahead and create a new one. I'll go through this flow super quickly, but we're not going to do any fund transfers or any advanced configurations here. Let's call this instance 1. Go ahead and click next. You can choose if you want to integrate this with the AWS S3 bucket or Azure Blob Storage, or you can have basically your private data persisted on a Kaleido hosted container. We have some new improvements here, some new configurations. So based on your requirements, the size of data that you're going to be sending and the amount of data that you need to store, similar to choosing a node, we have different t-shirt sizes for these instances as well right here. So go ahead and click finish. This will take 30 to 45 seconds to provision. Tons of really, really interesting improvements and metrics and monitoring has been added to all of these services, app-to-app, document exchange, and also basically the metrics and monitoring dashboards for your blockchain and for your overall business network right there. So we've created an instance, and the important thing that you have to do with document exchange and with app-to-app messaging is you need to create a destination or an inbox, somewhere that other folks can send you data and transfer data to you. And this is really, really important. This has to do with, basically our PKI infrastructure and our asymmetric cryptography that does sign verify for all of the transferred in-flight data, whether it's a message or whether it's a document. And this is really, really simple to do. The best practice here is just to let Kaleido do all of the heavy lifting that needs to take place inside of these services. So there is support for self-managed cryptography if you want to be the custodian, of your own keys, or if you want, a externally signed X509 certificate underneath your organization and your memberships. But the easiest happy path is to let Kaleido do all of that nasty asymmetric cryptography under the covers on your behalf. So what I'll do is I'll just click the easy button right here. And what this will do is this will provision the on-chain registry. This is what holds our PKI definitions of the network. And then it's going to create a certificate for my membership. And then it's going to take that certificate and it's going to issue a transaction, an invocation of this smart contract. It's going to bind that certificate on chain. And then underneath that definition, that certificate, we now can have key value pairs. And one of those key value pairs will be a destination and a unique certificate for the document exchange service. And it works the exact same way for the app-to-app messaging service as well. So this is, this takes a bit of time right here because this is, we're deploying a smart contract, we're building crypto material, and then we're actually invoking through a rather complex transaction. We're passing that certificate onto the blockchain along with a corresponding Ethereum address as well. So now we can choose a name for our destination, call it ABC. This should, ideally be an intuitive naming convention or naming structure for your counterparties to know where they're sending this data to, whether it's a message or whether it's a private document. So this will create that inbox, and then we'll be able to use the service. So again, the certificate basically is used, it's used on behalf of senders. So they'll take your certificate, they'll use that to encrypt data. You're the only one that has the private key. And then conversely, you take a counterpart certificate and you encrypt data that you want to send to them with that certificate as well. So staying in tune with some of the other services that we've looked at. This is going nice and slow, but we did all the heavy lifting and it'll ultimately go ahead and create that inbox or that destination for us. So I'm going to go ahead and hop out of there. It's complete. Maybe just got hung on that screen or my internet's not doing too great today. But we now have a destination basically to use. This isn't terribly useful unless you have another member in your network with a document exchange service and with a corresponding destination or an inbox. But this is sort of the easy happy path step to creating your first instance and your first destination. So great improvements there around document exchange and app-to-app messaging. Again, we'll be covering those either September 8th, I believe, is the next Tech Tuesday, or September 15th, one of those. So last thing to touch on is just, again, new improvements to IPFS and Chainlink, which are embedded directly inside of the blockchain context of your environment right here. So just click dashboard, or you can hover over any of the tabs right here and you can add corresponding runtimes, whether it's for IPFS or whether it's for Chainlink. So again, very, very simple to do this. Call it node number 1 in the IPFS cluster, click finish. You have a really clean, simple web UI to interact with when this thing is provisioned and live. And then similarly with Chainlink right here, call this node 1 as well. And the nice thing about Chainlink as well is we're going to serve you, directly the same way we show you node details. We'll show you all of the pertinent details, the Oracle address, the link address, username, password, etc., to log into the interface. So the main takeaway here is that we're continuously enhancing all of the services, and we're trying to expose all of the functionality that's actually been here for a long time inside of the product, but not give you, heavy or cumbersome administrative APIs in order to leverage that functionality. Everything will be directly embedded inside of the product. I guess the last thing to look at too is the Data Explorer. This can be particularly interesting just in the sense that it gives you very, very simple I guess, views of the pertinent state changes. So you can actually click on a specific transaction here. You can see the consumption of the gas. You could see the method that was invoked, for example. You know, anything that's important to your business network, you know, that's going to all be available here inside of the Block Explorer, inside of the smart contracts view as well. So we see that we've created quite a few smart contracts because we actually deployed our Chainlink service, we deployed our on-chain registry service, and I have my simple storage smart contract as well. So we see all of these were deployed by the actual system monitor node. Those were transactions that were done on behalf of the business network. But here we can see, you know, sort of our simple storage smart contract that we have available. Okay, I'm going to throw my email in the chat for you guys. If there are any things that come to mind after the call, or if you have any, you know, technical or commercial concerns, please don't hesitate to reach out. And thank you guys so much for attending today. One final thing, I guess, that I'll mention, it is free to sign up for an account inside of Kaleido, so you can explore all this functionality that I showed you. But you can also contact us directly inside of the console right here. Just use this contact us button. You can submit a sales ticket, a technical ticket, or a help desk ticket as well. Very, very simple to do, and that gets routed to the broader Kaleido team, business and engineering as well. So thanks so much for attending. Hope everyone's staying safe, healthy. Hopefully this was useful, and please don't hesitate to contact me or submit a ticket if you have any questions. Have a great day, and this is recorded, and we'll be sharing more information about upcoming Tech Tuesdays, the details on those. So stay tuned for that. We have some cool new features that we'll dig more deeply into, like the document exchange, like app-to-app messaging, and others. So thanks again, and signing off for now.